Hi, welcome to Okuma's IMTS presentation. I'm Wade Anderson, Product Specialist Manager for Okuma. Today I'm going to spend 15 minutes and give you a very fast-paced, very high-level overview of our primary vertical machining centers, horizontals, and 5-axis machines. So we do a lot in the vertical market, primarily with our Genos and our MB vertical machining centers. We have two different ranges of horizontal machining centers, our MA series and MB series. And then we have a wide array of universal machines, otherwise known as our 5-axis machines. The design concept for all machine tools begins with a thermal stability in mind. So we can make the greatest looking machine tool in the world, but if it's not thermally sound, it's not going to be accurate for the harsh type environments that we put our machines through on a day-to-day environment. So we spend a lot of time in a thermal stability room where we run the machines from -5 degrees Celsius up to 45 degrees Celsius and map out over 200 sets of data points that we use to understand how this machine reacts to different types of heat and humidity. This gives us information to know where we need to increase airflow, for an example, or create ambient air gaps. So we separate out heat sources like hydraulics or chiller units or even electrical cabinets. You'll notice on an Okuma mill, we never have heat sources mounted directly to anything of the base casting itself. That way our motion system is as accurate as it can possibly be. Anything that we can't engineer out, we use the mapping to come up with a thermoactive stabilizer system. So things like servo motors, for an example, creates heat. Motion of the machine creates heat. So our task C, thermoactive stabilizer C, is for casting. S is for spindles. We have sensors mounted in strategic locations all around the machine tool where we feed that information back to the OSP control. The OSP will then calculate different types of offsets that are needed to feed back to the servos themselves to adjust the kinematics of the machine based on heat. So let's take a look at the vertical machining center platforms. We have several different types of vertical models ranging from our Genos mills, our MB verticals, our Millac series, and our MA verticals. The ones I'm going to spend the most amount of time today talking about will be our Genos M and our MB because they share the same exact frame, and then the Millac series. So the 40-20 mill is the largest market segment in North America. There are more competitors in the 40-20 mill category than any other machining center category. So how do you know when you're just looking at all the different models with the sheet metal on, pretty much everybody's machine tool kind of looks the same. So how do you know what's laying underneath the sheet metal? Let's take a look at a standard run-of-the-mill C-frame machine. I'm not going to get into the semantics of the difference between C and L frame, but just think about a C as you look at the side of the machine. It creates a C-type shape. As that machine gets hot, it opens up and expands and contracts. There's also a concern when you look at some of these machines on how wide the base is itself. When you take all the sheet metal away and look at what your motion system is actually mounted to, you want to ask yourself, how wide is that base? How wide of a stance do we have? How much overhanging mass? The table on table stack up for a C-frame machine, your table on X-axis sits on top of Y-axis. So when that table moves back and forth to its extremities, left and right, how much weight is overhanging, because that changes the harmonic frequency of the machine. And then the throat depth. In order to have Y-axis travel, a lot of these style machines utilize a very large casting or a weldment where your spindle is mounted to create a throat depth for Y-axis to be able to travel in to create reach. That again creates harmonics, which could lead to chatter and other things. So let's take a look at our Genos and our MB series vertical machining centers. When we pull the sheet metal off, the first thing that you'll see is we utilize a double column construction. So we don't have overhanging mass because our X-axis is in the spindle overhead moving left to right. So it doesn't matter which extreme I go left or right, the machine harmonic doesn't change. Same with Y-axis. My table is in Y-axis. I go all the way forward or all the way back, the harmonic frequency of that machine structure doesn't change. It's a very sound, stable platform. We also utilize very simple shapes, rectangles, squares. We have built-in gussets on the double column structure itself. So we have predictable shapes and we have predictable growth that we then feed back to the task, the thermoactive stabilizer. So any kind of heat source we can't engineer out, anything that's moving from a heat generation standpoint, we can deal with from a kinematic standpoint. We also separate all the heat source from the machining environment. You will never see chips or coolant come directly in contact with that base casting. We use sheet metal liner all over the inside of that machine tool so that hot chips, cold coolant, things of that nature hits the sheet metal and is flushed out of the machine, does not come in contact with our base casting. All of our mills that I'm going to be talking about today utilize a Big Plus spindle system. So that's a dual contact spindle. So we have contact on the taper of the tool as well as contact on the face of the spindle. One very important feature of that, not only from a rigidity standpoint, but an accuracy standpoint. When we do tool changes or you take a cold spindle and you start it up, once you get about 5,000 RPMs on any spindle, centrifugal force forces that spindle open. Without that face contact, tools tend to want to suck up inside that spindle by as much as 25 microns. So having that Z-axis being repeatable and having that face contact eliminates all that, makes us a lot more accurate. So let's talk briefly about the Millac series. So we have Millac machines that range from a 44V all the way up to a Millac 1052V. These are traditionally big box weighed and geared headstock machines. They use a flywheel in the spindle, so it makes our geared headstock spindle an amazingly strong and powerful machine. We use box weighs on all the Millac series, and we range all the way up to an extended travel on our Millac 852 and 1052 up to 120 inches in x-axis. As I mentioned, all box weigh construction, these machines are a C-frame style machine, and as I alluded to earlier, I talked about how you got to be careful with C-frame style machines to make sure your table is supported, and when you move left and right to different extremes, you don't have unsupported mass. One thing you'll notice on the Millac machines, we utilize 4 box weighs, so all the way across that machine we have full support of that table. Even when we get into the 120-inch x-axis travel, we utilize an outrigger, which adds an additional weigh support on the outside edge. So again, we never have any type of table weight that is not fully supported. I'm a big fan of horizontal machining centers. The very first machine I ever ran from a machining center standpoint was a horizontal. A lot of people go from a vertical and then a horizontal, then to a 5-axis. I did just the opposite. I actually started on a horizontal and went back to a vertical. So we've got 2 different series of horizontal machining centers that we offer. Our MA series, that's our heavy series machining center. An MA 600, for an example, that's about a 56,000 pound horizontal machining center that's got strength and rigidity beyond compare. Then we have our MB series horizontal. That's a little bit lighter machine. So our MB 5000, for an example, is about a 26,000 pound, 28,000 pound horizontal machine. So it's a little bit lighter, still has an amazing strong strength and rigidity about it, but the lightness allows us to increase our acceleration deceleration rates to allow us to be able to get from feature to feature on a part much faster. So for an example, our MB 5000 Mark II, that currently is the fastest horizontal machining center in our entire product lineup. Incredible from a speed and accuracy standpoint. The thing I really like about horizontals is it gives me this chance to stack up more work on the work holding. So as I look at these pictures ranging from left to right, that's an example of a part where you're utilizing the horizontal to access different sides of the part, utilizing a PDQ work holding fixture to be able to access the front and both ends of the part. As I transition to the middle tombstone, that's a KME tombstone that has rotaries built into the tombstone, which allows me to index the work and be able to get to 5 sides of the part all in one clamping. And then looking at the AMROC tombstone, that's an example where I could stack up on all 4 sides of the tombstone multiple work pieces. So this one's showing 6 different places where you can have work stacked up, that increases my utilization time. It increases my length of time my spindle is in the cut. And the better I can utilize my spindle, the more spindle time I have running, the more money I can make on that machine tool. A common element that I like to talk about on our Genos and MB series, as well as our horizontals, is we utilize cast-in ball screw mounts and pre-tension ball screws. Again, that plays into our thermal-friendly concept and the accuracy we can expect out of these machines. Automation is such an important factor in today's manufacturing environment. All of our horizontal machining centers are automation friendly, meaning we can easily field retrofit. We can go from the 2 APC automatic pallet changer that comes standard on the machine tool. We can jump that from a 2 APC and automatically go to a 6 pallet pool or a 10 or a 12 pallet pool system. From there, we can also look at incorporating a FMS system. We work hand in hand with Fastems, so we can add anywhere from 20 all the way up to several hundred pallets onto these machines. Now the hot topic in the marketplace is 5-axis machines, the 5-axis platform. One key benefit of that is you can reduce the amount of fixtures you have. So 5-axis allows you to get to more sides of the part in one clamping and get more utilization again from your spindle in one work holding. Sometimes people get intimidated when you talk about 5-axis machining. They think about the blade type work where you're doing 5-axis simultaneous machining, and they worry whether or not they have the skill set able to be able to approach work like that. The reality is about 90 to 95% of the work that's available on the market is 3+2 work. So the machining process isn't that much different than a vertical or horizontal, but you're utilizing the rotaries to present the work in different areas to be able to access different parts of or different features around the part itself. So the most common ways to articulate the axes, the rotaries, is with a table type setup, what we refer to as a trunnion, where you have an A axis and a C axis. Then we jump into typically what's on a horizontal machining center, where you have a head table. So you would have a B or a C axis on the table that rotates, and then you have an articulating spindle in the A axis. Or when you get into really large work, you see head style machines, and that's where both rotaries are in the spindle itself. That is usually for large work pieces that's too large and cumbersome to be able to swing in a trunnion type setup or even a table setup. So a quick look at our Genos M465AX. This is a 400 millimeter platter trunnion machine. So the operator stands at the control, the trunnion is tilting to and from him. So all the work is accessed through the front door. This is a really great job shop style machine. It's got a lot of mass. It's about 17,000 pounds. So capable of handling everything from the aluminum work all the way up to Inconel and titanium style work. So it's a really great entry-level platform. When we jump into the MU series of our 5-axis machines, the most common ones that I'm going to talk to currently is our MU 5000 through MU 8000. So we have a 500 millimeter, 630, or 800 millimeter size platter. Our MU verticals are large trunnion style machines. We are dually supported. We don't have an unsupported trunnion. We have support on both left and right sides of the trunnion. And this is a very ergonomically friendly machine. As the operator walks up, the trunnion is tilting to and from him in this type of an orientation. But the unique feature is with the way the trunnion is mounted is we can automate from the back of the machine tool. That allows us to tie in APCs or FMS systems, and the operator still has full access to the front of the machine. Hopefully this design is starting to look familiar. We utilize the same double column type construction that we've talked about previously, simple shapes for thermal friendly setup, and a very minimum throat depth. Thank you for your time today. If you have any questions, please reach out to our local distributors. We look forward to talking to you.